So integral of cos 2x the whole power 4 dx, right? So what we'll do is integral of, how can you write this as? Well, I'll write it here. Integral of, can you write it as 1 plus cos 4x by 2 the whole square times dx? Can you do that? 1 plus cos 4x by 2 the whole square times dx. Correct? So what will it be? 1 by 4 will come out. This 4 will come out. You have 1 plus cos square 4x plus 2 cos 4x times dx. Okay. So 1 by 4 into, see, I'm not integrating here itself. 1 plus, how can I write this cos square 4x as? I can write it as 1 plus cos 8x the whole divided by 2 plus 2 cos 4x times dx. So 1 by 4 into integral of 1 plus half is 3 by 2 plus cos 8x by 2 plus 2 cos 4x the whole times dx. This is going to be equal to 1 by 4 into, observe, 3 by 2 times dx is 3x by 2 plus cos 8x by 2 is going to be, integral of cos 8x by 2 is going to be sin 16x divided by 8. 8 into 2 is going to be 16 plus 2 times integral of cos 4x will be sin 4x divided by 4 plus c. Okay. So this is going to be 3x divided by 8 plus sin 16x divided by 64 plus, this will cancel this 2 times. It will be sin 4x divided by 8 plus c. So correction here. So it will be sin 8x divided by 16 plus sin 4x by 2. So when you combine this, you are going to get the final answer as 3x by 8 plus sin 8x by 64 plus sin 4x by 8 plus c. So integral of sin square x divided by 1 plus cos x. How will you write it? Integral of sin square x divided by, how can you write 1 plus cos x as? It is 2 cos square x by 2. It is 2 cos square x by 2, right? Times dx. So integral of, how can you write sin x in terms of sin x by 2 and cos x by 2? So you can write it as, so you can write it as 2 sin x by 2 cos x by 2 the whole square, right? You have a square here. So it will become 4 sin square x by 2 and cos square x by 2 the whole divided by 2 times cos square x by 2. 2 will cancel this 4 2 times. So cos square x by 2 and cos square x by 2 get cancelled. So it is going to be integral of sin square x by 2 times dx. Right. So 2 sin square x by 2, how can you write it as? 1 minus cos x is 2 sin square x by 2. Right. So 1 minus cos x dx. Because what did I say? In integration, the ultimate aim is to eliminate the denominator. So that's why we had to do this process. Right. So integral of 1 minus cos x dx is going to be, what is integral of dx? It is x minus what is integral of cos x dx? It is going to be sin x plus c. So answer is x minus sin x plus c. So let's look at the 13th one. So when you look at the 13th one, it is integral of cos 2x minus cos alpha divided by cos x minus cos alpha, right? Times dx. So how to solve this? Cos c minus cos d. What is the formula? So it is going to be minus 2 sine of c plus d by 2. So 2x plus 2 alpha by 2 is x plus alpha. I'm not writing an extra step. I hope you could understand. So 2x plus 2 alpha, the whole divided by 2 is x plus alpha. Sine of 2x minus 2 alpha divided by 2 is x minus alpha, the whole divided by, what will the answer, the denominator be? So minus 2 times sine of x plus alpha by 2 sine of x minus alpha by 2. Make sense? So minus 2 are gone. So what is that you are left out with? Sine of x plus alpha into sine of x minus alpha by sine x plus alpha by 2 sine x minus alpha by 2. Okay. Now what we can do to this is integral of this sine x plus alpha. I can write it as 2 times sine of x alpha by 2 cos of x plus alpha by 2. Why is it so? Because sine theta can be written as 2 sine theta by 2 cos theta by 2. So theta here is x plus alpha. Make sense? See, all I'm trying to do is I'm trying to write the numerator in terms of denominator so that the common terms will get cancelled. I'm trying to eliminate the denominator only. Okay. So 2 sine x plus alpha by 2 cos of x plus alpha by 2. Similarly, tell me what am I supposed to write here? 2 sine of x minus alpha by 2 cos of it's x minus alpha by 2 only, same angle. Right? The whole divided by sine of x plus alpha by 2 sine of x minus alpha by 2. So sine of x plus alpha by 2 sine of x plus alpha by 2 is gone. Sine of x minus alpha by 2 and sine of x minus alpha by 2 is gone. So they both get cancelled so that we only have the numerator left out throughout. What I will do is I have 2 cos of x plus alpha by 2 cos of x minus alpha by 2. There is an additional 2 that is there. So I'll take one of the 2's outside and I will write it as 2 times integral of, now concentrate. What is 2 cos x plus alpha by 2 into cos of x minus alpha by 2? What is 2 times cos c into cos d equal to? So cos into cos comes, it is cos. So cos of c plus d plus cos of c minus d. So what should I write it as? Understand the logic here. There are 2 2's here. One of the 2's I took it out. That is this one. Okay. I am writing. So what was the question? Integral of cos 2x minus cos 2 alpha. So integral of cos 2x minus cos 2 alpha, the whole divided by cos x minus cos alpha dx. Not sure how much you remember. What step you remember? First and no need. So can I leave those 2 steps? What did I do? I applied cos c minus cos d. So we got minus 2 sine of x plus alpha by 2 into cos of x minus sine of x plus alpha by 2 into x plus alpha and x minus alpha. Yeah, 2 sine of x plus, okay, I'll write it again. 2 sine of x plus alpha into sine of x minus alpha with a minus sign here and minus 2 sine of x plus alpha by 2 cos of, not cos, sine of x minus alpha by 2, minus 2 and minus 2 got cancelled. Then what did I write the sine of x plus alpha as? 2 sine of x plus alpha by 2 cos of x plus alpha by 2, and the sine of x minus alpha I wrote it as 2 sine of x minus alpha by 2 cos of x minus alpha by 2 only. Same angle, no? The whole divided by sine of x plus alpha by 2 sine of x minus alpha by 2. So sine x plus alpha by 2 and sine x minus alpha by 2 will cancel. So I took one of the 2's outside and what did I write it as? I combined it with 2 cos of x plus alpha by 2 cos of x minus alpha by 2. So what will you get? 2 into, what is 2 cos x plus alpha by 2 to cos of x minus alpha by 2? Cos of c plus d. So x plus alpha by 2 plus x plus alpha by 2 is going to be x plus cos of x minus alpha by 2 minus x minus alpha by 2 will be cos alpha. So you need to find the integral of this, right? Actually, one more step you would have been done. So 2 times sin x plus 2 times x cos alpha plus c. We'll move on to the next one. So let's do the 14th question. So what is integral of cos x minus sin x divided by 1 plus sin 2x? Okay. See, whenever you have this 1 plus sin 2x, no, you can write this 1 as cos square x plus sin square x, and you can write the sin 2x as 2 sin x cos x. So a square plus b square plus 2ab is going to give you cos x plus sin x the whole square. Okay. So integral of, it is going to be cos x minus sin x the whole divided by, it is going to be cos x plus sin x the whole square times dx. Now what we can do is, if you take this cos x plus sin x as t, if you take cos x plus sin x as t, then you will get minus sin x plus cos x dx is equal to dt. So what will the answer be? Integral of dt divided by t square. So it is going to be minus 1 by t plus c, or it is going to be minus 1 divided by, what is going to be the value of t? It is cos x plus sin x plus c. I hope it is clear, right? So whenever you have the combination of cos x plus sin x and the numerator is cos x minus sin x, right, you can take one of the values as t. So mostly you take the denominator only as t. So whenever there is a combination of tan and secant, always think in this format. You know that the derivative of tan is secant square. Means in a problem, if you have secant square, you can take tan as t and then proceed. Or else, if you want to find the, if you know the derivative of secant x, what is it? It is going to be secant x tan x. So if there is a power, if the power of secant in the problem is 1, and you have a tan also as a combination, then there is a high chance that you can take secant x as t. So that's the logic. So if I look at this problem, I can definitely not go with the first logic because I don't have secant square in this problem. So I need to think of second logic, because secant power 1x into tan power 1x, for which I will borrow one of the tan 2x from tan cube x, so that I can write the same thing as tan square 2x into tan x, or I'll write it as secant 2x into tan 2x dx, where this tan 2x into tan square x put together is what is tan cube 2x. Makes sense? Now, integral of this tan square 2x, I can write it as secant square 2x minus 1. Right? I can write it as secant square 2x minus 1 into, you have secant 2x into tan 2x dx. Now things are sorted. If I put secant 2x as t, then this will come as a function of dt. Clear with that? So secant 2x, if I put it as t, that comes out as secant 2x into tan 2x multiplied with the derivative of 2x, which is 2 times dx. Am I clear with this? So what will happen? This will be equal to dt. So secant 2x into tan 2x dx is equal to dt divided by 2. So what will happen to this expression? Integral of secant square 2x minus 1 will become t square minus 1, right? T square minus 1 into dt divided by 2. So 1 by 2, I will take it out. 1 by 2 into, what is the integral of t square? It is t cube by 3. But what is t cube? What is t in the first place? Secant 2x. So, okay, I'll write this step. T cube by 3 minus, what is the integral of 1? T. So this can be written as half into, what is t cube? Secant cube 2x divided by 3 minus secant 2x, right? Plus c. So answer should be secant cube 2x divided by 6 minus secant 2x divided by 2 plus c, or you can write it like this also. Okay. Right. If you look at this problem again, whenever you have this tan raised to the power of something, right? Especially if it is greater than 2, what you can do is you can write it as tan square x into tan square x, right? So here, can I write it as tan square x into tan square x dx? So what I'll do to one of the tan square is I'll write it as secant square x minus 1, right? So integral of, I'll write this as secant square x minus 1 into tan square x dx. Now you tell me, what can I do to this? So I can write this as integral of secant square x into tan square x minus tan square x, right, dx. Can I do like this? Right. Now, if I take this term, right, if I take secant square x into tan square x dx, so integral of, I'll write it as secant square x into tan square x dx minus, here I have integral of tan square x. Again, tan square does not have a direct integral. So again, you should write this tan square x as secant square x minus 1 times dx. Make sense? Now tell me, what can I do to this? In this case, I can put tan x as t, so that I'll have secant square x dx as dt. So this will become t square, secant square x dx will become dt. So integral of t square dt is what you're going to have minus integral of secant square x dx. You have a direct integral. So you have a direct integral for it. So what is it? What is the integral of secant square x? Tan x minus, what is the integral of 1? X plus c. So this one alone, what can we do? We can write it as t cube divided by 3 minus, this is going to be tan x plus c. So what is t? Tan, no. So it is going to be tan cube x divided by 3 minus tan x plus c. So this will be the answer. So the idea is here is numerator is greater than the denominator. The power of the numerator is greater than the denominator. So here you have third. Here you have the power as 3. Here you have the power as 2. So what you will do is sin square x into cos square x, spread it to each term. So this is going to be integral of sin cube x divided by sin square x into cos square x plus cos cube x divided by sin square x into cos square x, right? So sin square will cancel sin cube 2 times and you're left out with sin x, right? And cos square cancels cos cube and you're left out with cos x in the numerator. Now what I'll do is integral of sin x by cos square x is there. No, I will write sin x divided by cos square x. I'll write it as cos x into cos x, so that sin x divided by cos x is going to give me tan x and 1 by cos x will give me secant x. So integral of, can I directly write it as secant x into tan x dx plus integral of cos x by sin square x. I will write it as cos x by sin square x. I'll write as sin x into sin x. Cos x by sin x is going to be cot x into 1 by sin x is going to be cosecant x. So you will have cosecant x cot x dx. So what is going to be the answer for integral of secant x tan x? It is secant x, and integral of cosecant x cot x is minus cosecant x plus c. That's the answer. So what we can do is, can I write cos 2x as cos square x minus sin square x, right? So it is going to be cos square x minus sin square x plus this is going to be 2 sin square x the whole divided by cos square x, right? So minus sin square x plus 2 sin square x is how much? It is going to be plus sin square x. So tell me one thing, cos square x and this is going to be plus sin square x. So cos square x plus sin square x is 1. So integral of 1 divided by cos square x dx is going to be integral of secant square x dx. Answer will be tan x plus c. See, if I multiply and divide it with 2, I can do that only if I have the powers to be the same. So you have the formula for 2 sin x into cos x, but you don't have the formula for 2 sin x into cos cube x. Right? So is there a way where you can manipulate and convert it in that form? You can borrow one of the cos x from cos cube x and then try to manipulate it. So that you will have 1 divided by this, you can write it as sin x into cos cube x. I will write it as cos x into cos square x dx, because my idea is I want to take that cos square x to the numerator so that it becomes secant square x. So when it becomes secant square x, there is a possibility if I have tan x in the problem, I'll be able to solve it fast. Did you understand the logic? Right. So now what I can do is I will multiply and divide it with 2. So I'll multiply and divide it with 2 so that, did you understand what I did? I put a 2 outside, I 2 here, so that this 2 sin x cos x is going to be treated as sin 2x, right? So the whole expression will get changed as 1 by cos square x. I can write it as secant square x divided by this. I can write it as sin 2x dx. But since I have secant square x, it is always important that I have a tan x in that problem. So what I will do is I will write this sin 2x as 2 tan x by 1 plus tan square x. So 2 into integral of secant square x dx divided by, it is written as 2 tan x divided by 1 plus tan square x. 2 and 2 will get cancelled, right? So this will be equal to integral of 1 plus tan square x divided by tan x, right, into secant square x dx. Make sense? Right. So observe, this can be written as integral of 1 by tan x. So 1 by tan x plus tan square x by tan x is tan x into secant square x dx. Now I will take the tan x and put it as t. If I put tan x as t, I'll write it here. If I put tan x as t, then I'll get secant square x dx as dt. So this whole thing is going to be dt, and this will be 1 by t plus t, right? So integral of 1 by t plus t times dt, what is it going to be? Integral of 1 by t is log t, log of t. But what is t? T is tan x. So log of mod tan x plus integral of t is t square by 2. But what is t? Again, tan x. So it will be tan square x by 2 plus c. So this should be the answer. Log of mod tan x plus tan square x by 2. What is the formula for cos 2x? It is cos square x minus sin square x, the whole divided by, it is going to be cos x plus sin x, the whole square times dx. Now listen to this. Cos square x minus sin square x, if you treat it as a square minus b square, it can be written as a minus b into a plus b. So you can write this as integral of cos x minus sin x into cos x plus sin x, the whole divided by, it is going to be cos x plus sin x, the whole square. So 1 cos x plus sin x and 1 will get cancelled. I mean, 1 of the cos x plus sin x will get cancelled. So that you're left out with cos x minus sin x by cos x plus sin x. Again, what is the logic? Put cos x plus sin x as t. Then what will happen? Then you will have cos x minus sin x times dx is equal to dt. I hope you understood why is it so. Because the derivative of sin x is cos x. Derivative of cos x is minus sin x. So numerator will become dt and the denominator will be t. Answer will be log of mod t, but t is nothing but cos x plus sin x plus c. This should be the answer. Log of mod cos x plus sin x plus c. So the problem is integral of sin inverse x cos x. So this will be integral of sin inverse of What is cos x? Sine of pi by 2 minus x. So sine inverse and sine will get cancelled. It's not like they're getting cancelled, but sine inverse of sine is going to give you the angle itself. So answer will be pi by 2 minus x times dx and the integral of it. So what is the integral of pi by 2? It is pi x divided by 2, right? Minus, what is the integral of x? It is going to be x square by 2 plus c. So pi x by 2 minus x square by 2 plus c should be the answer. So let's come from the beginning. What is the idea here? Cos x minus a into cos x minus b. I want the same kind of terms in the numerator so that those terms get cancelled out. So for that, what I will do is, I will multiply it with sine of b minus a and compensate it with sine of b minus a. And what is it I'm left out with? Here I'm left out with cos of x minus a into cos of x minus b, right? So, but sine of b minus a, how can you write it as? So I want x minus a to come. So I will write it as sine of, I'll add an x, I'll subtract an x. So the x that I added, I'll combine it with minus a, and the x that I subtracted, I'll combine it with plus b. So that this can be written as sine of x minus a minus of x minus b, right? Now tell me, how should I write that as? So I'll take this x minus a as a and x minus b as b. So it is going to be sine a cos b minus cos a sin b, the whole divided by cos x minus a into cos x minus b, and here it is going to be cos x minus a into cos x minus b. So cos x minus b and cos x minus b will get cancelled. Cos x minus a and cos x minus a will get cancelled, so that what is it you're left out with? So this whole thing, I'm talking only about this part. So this part got converted to this. Remember, there is 1 by sine of b minus a outside. So the whole integral of this can be written as 1 by sine of b minus a out of the integral into integral of sin x minus a by cos x minus a is going to be tan of x minus a dx, okay, minus sin x minus b by cos x minus b can be tan of x minus b dx. So what will the answer be? 1 by sine of b minus a into, what is the integral of tan? Log of secant x minus a minus log of secant x minus b. So this is going to be inside the bracket. So this can be written as 1 by sine of b minus a into log of, you know that log a minus log b is log of a by b. So log of secant x minus a divided by secant x minus b plus c. So this should be the answer. So 23rd question, integral of sin square x minus cos square x by sin square x into cos square x. So if you observe, the power in the numerator and the denominator are same. So what you do is spread the sin square x into cos square x in the denominator to each term in the numerator. When you do that, you will get integral of sin square x by sin square x into cos square x. So you will have 1 by cos square x. So 1 by cos square x will become secant square x dx minus integral of cos square x by sin square x into cos square x. So cos square will get cancelled. You will be left out with 1 by sin square, which is cosecant square x dx. So integral of secant square x is tan x, and integral of cosecant square x is minus cot x. So minus of minus will become plus cot x plus c. This will be the answer. So it is option A. So if you look at the 24th problem, right, it is integral of e power x into 1 plus x divided by cos square of e power x into x. See, whenever you have anything inside the trigonometric function other than x, right, mostly that will be taken as t. So here, if you observe, if you take e power x into x as t, the numerator is the derivative of it. Make sense? So it is e power x into 1 plus x. So if I take e power x into x as t, that implies e power x into 1 plus x dx is dt, integral of dt divided by cos square of t. That's it, no? So this thing is dt divided by cos square t. So 1 by cos square t is secant square t dt. So integral of secant square is tan. So tan t, what is t? That is x into e power x plus c, and this should be the answer.